Hi everyone, in this video, I'm going to go over the importance of molarity and stoichiometry. Okay, so the concentration of molarity, which is the uppercase M, as you already see here, is contain mole over liter, which means that this concentration will allow us to go between mole and liter. So this is our conversion factor. Will also allow us to feed this mole into mole to mole ratio as well. So as you see here, if you know volume of the solution, you know the concentration, you can then use the concentration to change this volume into mole. Okay, so this mole can then be used to convert to mole of another species through the chemical equation. Not only that, if you know mole, you can also convert this into grams or molecule as well, using molar mass and using Avogadro's number. Okay, so it's depend on what you want to go. Let me show you an example. Okay, so example of this can be found on page 100 of your lecture manual. Okay, so I'm going to go over example 1B and 1C. I'm going to let you do 1A yourself. Okay, so let's take a look at 1B and 1C real quick. So this reaction right here is involved with the reaction between sodium carbonate and nitric acid. Okay, so it's going to produce sodium nitrate and carbon dioxide and also water. Okay, so let's take a look at what is given to us. Okay, so it tells us that we have 15 milliliter of 0.263 molar of nitric acid. So that means we are given the information of nitric acid. This nitric acid will be mixed with 20 milliliter of 0.417 molar of sodium carbonate. So that means pretty much the problem asks us that if these two mix, right, how many mole of carbon dioxide, which is this one right here, could be formed. Okay, so note that this problem gives us information of the two reactants. One is nitric acid, both volume and concentration. The other is sodium carbonate, which is volume and concentration. Whenever the two information of the two reactants are given, this problem is going to be the limiting reactant problem, which means you will be able to find out how many mole of carbon dioxide will be able to form based on what would be the limiting reactant. So that means we will need to set up two separate equations. Okay, so one is using information of the nitric acid. Okay, the other would be using the information of the given sodium carbonate. Okay, so I'm going to start with the first one. Okay, so let's take a look at the first given information, which is of nitric acid. So it gives us volume and concentration. Note that whenever that you are looking at number, we are going to always start with the number that contain 1 unit. Okay, so 15 milliliter contain 1 unit milliliter. This seems to be 1 unit, but it's not. Okay, so uppercase M, whenever you see this, go ahead, replace this with mole over liter. Okay, so this contains 2 units. It contains a unit of mole and it's contains a unit of liter, which is going to be used as conversion factor. Okay, so I'm going to go ahead, start with 15 milliliter. Because we have milliliter, but our concentration, this is mole over liter. So we need to convert this milliliter to liter first. Okay, so that would be our first step right there. Go from milliliter to liter. And then use the concentration, okay, so which is mole over liter, to convert to mole of nitric acid. I don't want to know mole of nitric acid. If you stop right here, this is mole of nitric acid. But I don't want to know mole of nitric acid. I want to know mole of carbon dioxide, which is of the product. So therefore, we will need to convert these by using the mole ratio. Okay, so every 2 mole of nitric acid will produce 1 mole of carbon dioxide. So therefore, in this case, the ratio would be 1 to 2. Cancel all the unit. You are going to be left with the unit of mole of carbon dioxide. Okay, so that means if you have this volume with this concentration of nitric acid, this is how much CO2 can be made. I'm going to do the same thing as well with the other reactant, which is sodium carbonate. Okay, so we are going to start with the same thing, volume of sodium carbonate multiplied by the conversion factor between liter and milliliter, and then multiply by the concentration. Okay, so again, this is going to be mole over liter. So therefore, in this case, you are going to put mole over liter, so that way liter can cancel each other out. Okay, and you are going to be left with mole of sodium carbonate. I don't want the mole of sodium carbonate. I want mole of CO2. So therefore, we're going to use mole to mole ratio again. Okay, so to get mole of CO2. Now we have the number of mole of carbon dioxide that can be made from the given available of the amount of sodium carbonate. So together, if you consider these two, okay, so you probably notice that we don't have enough nitric acid to make this many mole of CO2. So therefore, the only amount that we can make would be just 0.001973 because this is come from the fact that nitric acid is our limiting reactant. Okay, so we don't have enough nitric acid to make that much. We have only enough to make this much. So that means this is going to be our theoretical yield. Now let's take a look at the follow-up question. Okay, so what if we know, so this is the mole of gas. What if we know temperature and pressure? Can we find out volume? The answer is yes. Okay, so that's going to be the follow-up question C. According to our previous answer in B, okay, so with this many more right here that we have, okay, so we want to find out what would be the volume of that CO2. Okay, so in this case, as long as we know temperature and pressure, we should find out the volume through pif-nerd. Okay, so pif-nerd will allow us to find out volume by you plug in mole of CO2 that can be made, multiplied by the R constant. Therefore, temperature and pressure have to be based on that. So that means in this case, because of R contain the Kelvin unit, so therefore temperature have to be in Kelvin, and then pressure have to be in ATM. Okay, so convert that 756 millimeter mercury into ATM. You are going to get volume in liter, right? Because this is the R in liter. So it 1 in milliliter, so therefore you are going to convert to milliliter. What does it mean? Okay, so it means that with those concentration and volume that you have from part B, this is how much CO2 that can be made. If you run this reaction, this amount of CO2 that can be made will occupy this much space, which is going to be 48.5 milliliter. So if you run this in the eudiometer, such as in the lab, okay, so this is going to be the reading that you will read from the eudiometer. Next, I would like you to attempt part C yourself. Okay, so I would like you to pause the video and complete this. When you are ready, then let's resume the video again. Now let's check your work. Okay, so same thing here. We are given the volume and the concentration. We are given another concentration as well. So this one, it asks us to find out the volume of nitric acid with this concentration. And it's asked us that this nitric acid is going to react with this volume and this concentration of sodium carbonate. Okay, so that means when you are looking at this, again, you are going to look for the number that contain 1 unit. Again, the milliliter would be the 1 unit. Okay, so this number would contain only 1 unit because those M are 2 units. Remember, it's the mole over liter. So therefore, I'm going to start with that. Okay, so I'm going to start with milliliter of sodium carbonate. Convert that to liter because this molarity is in liter. Okay, so this molarity concentration is mole over liter. So I'm just going to put mole over liter there. If you stop here, you get mole of sodium carbonate. Okay, so I don't want to know more of sodium carbonate. I want to know volume of nitric acid. So that means in this case, we need to go ahead, use the connection, which is the mole to mole ratio, right? Because mole to mole ratio will allow us to go from mole of sodium carbonate to mole of nitric acid. So in this case, it's come from the balanced chemical equation. Okay, so it's 2 to 1. Okay. Once you know mole of nitric acid, the concentration will allow us to go from mole to liter. Remember, every time you see uppercase M, it's always the conversion between mole and liter. So in this case, mole should be on the bottom because we want to cancel. So mole, liter should be on top. These mole and liter can always be swapped. Okay, so depend on what you want to cancel. In this case, I want to cancel mole. So mole have to be on the bottom. Okay, so liter would be on top. And because we want in milliliter, so the last step would be convert this into milliliter. Okay, so cancel everything out. You're going to be left with milliliter of nitric acid. And that would be the answer. Here are more examples that you can practice yourself. I would like you to do this yourself. Okay, so once you're done, then please check your work and answer against the key that posts on Moodle.